Mhm. Boston to DC, and which date? And the return? Oh, but you said you wanted to quote them as one way? Okay, so let's do October 2nd first. Okay, and did you have a time in mind for the Boston DC? Well, there's a lot of places.
Hello, Grace.
Okay, so the
Welcome.
base rate is coming at $167. The taxes and fees, which are subject to change as of ticketing, are $10.10. The
Can you
total
hear me,
comes to
Grace?
$177.10. That is for the 7 a.m. flight, yes. So those are gonna be higher.
Grace, I don't see that you have your microphone activated, and that's fine. If you can hear me, if you can go to the chat feature and just say hi or yes, I can hear you, that'd be great.
Okay, so the 8 and 9 have the same fare class, so they're gonna be the same price. So I'm gonna quote the one at 8 in morning.
All right.
Okay, so this one is at $212 for the base rate. The taxes and fees are $10.10. Remember, those are subject to change until ticketing. The total comes to $222.10.
Okay, so I'm going to work through a few problems.
That's at 9:30.
Take a look at some of the problems here. So rewrite each of the equations in exponential form. When you're working on this kind of problem with logs and exponents, I think it's a good idea to write at the top of your paper.
Okay, so this one is coming at $167 per person. The taxes are
B
10.10.
to the x power is equal to y. I like to use x up here because then I'm think of it as exponent and b for base. So b to the x power equals y. And then we use these double-sided arrows, which means if and only if the log base b of y is equal to x. And there those x and y, this relationship is the same. So b raised to the x power equals y. So if we look at number 2, for example, log base 2 of 8 equals 3 implies that 2 raised to the third power equals 8. And we know that's true because 2 times 2 times 2 equals 8. Let's look at another one. Let's look at number 5. Number 5, the base is 7. And so the exponent for 7 would be negative 3. 7 to the power of negative 3 is equal to 1 over 343. And you can put that in your calculator. 7 raised to the negative third power, is that equal to 1 over 343? And 7 cubed is 7 times 7, which would be 49, times 7 again would be 343. But the negative exponent indicates the reciprocal. And so it's 1 over 343. And this is also a true statement. In the next few problems, we're asked to do the same thing, but in reverse. So rewrite each of these equations in logarithmic form. Let's look at 8.
How many people do you have? 23?
So the base is 5, so we write log base 5, and it's a subscript, log base 5 of 625, and this is equal to 4.
Okay, and what 5 did you do? The one at 6?
Let's do one more. Look at number 9. Number 9, we've got
67,
log base 6 of 1/6 is equal to negative 1. And so 6 raised to the negative 1 power indicates the reciprocal, so it's 1 over 6. So this is also a true statement over here. Log base 6 of 1/6 equals negative 1. Then down in the next one, we're supposed to practice using properties of logarithms. And so the natural log is log base e. That means that ln of x is the same as saying log base e of x. You won't ever see this written though, because that's what this means. The natural log of x is log base e of x. So the natural log of e, what would cause it to be, what's the exponent to which you would raise e so that the resulting value is 1, and that would be 0, because e raised to the 0 is 1. Anything raised to the 0 power is 1, with the exception of 0. So if you look at number 18, it's also going to be equal to 0 because 6 raised to the 0 power would be 1. And then if we look at one like number 16. Number 16, we've got 4 raised to the power of log base 4 of 2x. And these 4 and the log base 4 cancel each other out. And so the answer of this is just 2x.
Okay, and what was the time that they were looking at?
Log base 9 of 9, that'd be 1. There's several chances here for you to practice and struggle a little bit. Look them up if you need to. You can also call me if you need help. Solve the following equations. With a lot of these, you want to take them from log base form to exponent form, and then see if you can equalize their bases. Like if you look at 23, we can rewrite this as 5 to the x is equal to 625. And so our challenge is to write 625 as a power of 5. And if we get our calculator, you find that 5 to the x, 625 is the same as 5 to the 4th power. You take 5 and multiply it by itself 4 times. 5 times 5 is 25, and 25 times 25 would be 625. But they're putting these in terms of where they have the same base. We can then cancel the base and just say x equals 4. And so that would be the answer for number 23. That 5 raised to the 4th, log base 5 of 625 equals 4, and that's true because 5 to the 4th is 625. Number 29 is a little more challenging. Let's do 29. 16 and 8. Well, see, 16 is not a power of 8, but they're both powers of 2. And so I can say 16 is 2 to the 4th power times x plus 1. And 8 is 2 to the 3rd power. And that's raised to the x plus 3 power. And our power rules, our power of a power says that we multiply the powers. And because we have the same bases, we can just think of this as 4x plus 4, distributing the 4 times both of those, is equal to 3x plus 9. If I subtract 3x from both sides, I get x on the left. If I subtract 4 from both sides, I get 5 on the right. And so x equals 5 would be the answer here. And you can always plug that 5 back into where you see x in the original equation to see that it works. 16 raised to the 5 plus 1 power, and then 8 raised to the 5 plus 3 power, and you can see that those work accordingly. If you need help, you're struggling here, please don't hesitate to call me. This is my Google Voice number that I set up to communicate with students. So this is 801-413-3363. And you can call me or text me there. If you're calling, please feel free to call between 9 and 5. If you text, you can text anytime, and I'll just get to it when I'm able. If I'm not able to get to it in the evening, then I'll deal with it in the next morning. All right. Hey, all, have a good evening. Good luck with your homework. Practice